All right, let's dive into something that sounds so simple on the surface, but really starts to bend your mind when you look closely. Time, or more specifically, the idea of now.
Exactly, because we think now is universal. You look at your watch, I look at mine, and we agree. But in physics, that agreement, it breaks.
It breaks because light isn't instant. Information takes time to get from A to B, which means there's no such thing as a natural, universe-wide now.
And that creates a huge problem. I mean, how do you simulate a universe if you can't even define what time it is everywhere at once?
That is the core question for today's deep dive. We've got this fascinating set of notes here from a dialogue between a user, Zainad Chat, and an AI, and they work out this incredibly rigorous framework using something they call an external reference.
It's a really deep, almost philosophical way of structuring things. The source material is very clear. You have to separate reality into three distinct worlds.
Okay, what are they?
First, you have the mathematical world. Think of this as the code, the software, like a Blender file where all the calculations happen. Then there's the display world, which is your monitor. And finally, the observational world.
Okay, wait, hold on. The display world. Why is the monitor its own separate world? Isn't it just, showing us the math?
Ah, see, that's where people get tripped up. The monitor is a 2D projection. It's a flat picture of 3D math. It's a translation layer, and that translation can hide things or even distort them.
I see. So the pixels are an interpretation, not the raw data itself. Which brings us to number 3, the observational world. The notes call it the dummy doll, and they get weirdly specific. They define the observer as the midpoint between the eyes.
Yes, and that's critical. It turns a vague idea, the observer, into a hard coordinate, a precise point in space. That's the camera.
So you have these 3 worlds, math, monitor, and the dummy doll's viewpoint. But something has to be in charge of all of them. That's the external reference, right? The one running the show.
And they have to be external. They are not in the simulation. They don't exist at coordinate 0, 0, 0. They're the ones who point to an empty spot and say, okay, that is 0, 0, 0.
They assign the coordinate system.
They define it. They set the stage.
Which leads to this grammar rule in the text that I found. I found it fascinating, the active voice rule. It says you can't say, the sun is at z equals minus 1,000.
No, you can't.
You have to say, the describer placed the sun at z equals minus 1,000.
It sounds a little pedantic at first, but it's a kind of safety mechanism. If you say the sun is there, you're treating the coordinate like it's a fact of nature. But if you say it was placed there, you're constantly reminding yourself that coordinates are a human invention, a map we drew.
A map. Okay, that makes sense of this other image in the notes, the light clock diagram. You've got these zigzagging yellow and pink lines. It looks like a physics experiment. But the notes are very explicit. The AI says this is currently just Euclidean geometry.
And that's the map versus the territory.
From Alfred Korzybski. The map is not the territory.
Exactly. The Blender model, those perfect zigzag lines,
Yeah.
That is just the map. It's the mathematical world. It's not the territory of physics yet.
Because in the real territory, light has a speed limit. In the Blender map, though, your calculations are instant.
Think of it like a map of a city versus driving through it. On the map, you can trace a route in a second. But the territory has traffic. The notes are clear that they haven't turned on the traffic yet. The simulation is just a set of definitions, not a running physical process.
And if you forget that, you start confusing the map with reality.
Which is how you get paradoxes. The external reference can assign coordinates to everything simultaneously, but those are just labels. In the territory, the dummy doll has to wait for the light to actually travel and hit its eyes.
So the real clarity here comes from separating the describer, who sets the stage, from the observer, who actually has to watch the play unfold in real time.
The describer has the God view. The observer only has their local view. This framework just forces you to be honest about which one you're talking about.
It's a humbling thought, really.
Yeah.
That all our models of the universe are just that. Models. They're tools we made.
Very powerful tools. As long as we remember, we're the ones holding them.
Well, we've covered everything from 3D software to the nature of existence. So here's a final thought to take with you. If every coordinate, every clock, is just a definition someone imposed, what happens to your understanding of reality when you realize you might have been mistaking the map for the territory your entire life?
That's the question, isn't it?
Thanks for diving in with us. We'll see you on the next one.